This video has 18 practice questions, 26 if you count the side-by-side examples. If you want to skip past my explanations of things and you just want to see the questions and answers, go to the description and there will be a list of timestamps that tell you where the questions are. So just wait 10 seconds for the answer to pop up, and if you got it right, you can skip to the next question. So to help you get a baseline idea of what you know versus what you don't know, I want you to pause the video and see how many of these 6 epithelium you can identify before I say anything. Remember, when you're thinking about epithelium, you should ask yourself how many layers and what is the shape, because that's either going to give you the name or give you enough information to tell it apart from the others. So if we look at this first example, we know that it is simple squamous because simple tissues have one layer. Squamous cells are flat. And because of how thin this is, you should recognize that this could only be one layer of flat cells. You should also know that it's not adipose because you're seeing many nuclei here, and in adipose, the bubble that you're seeing is one cell, therefore there will only be one nuclei in the bubble. The second one is simple cuboidal because this is one square-shaped cell with a circular nuclei, and if you keep going away from the open space, you hit a layer of tissue that looks different, so therefore you're out of the epithelium. So you're just seeing one row of square-shaped cells around the open space. Now sometimes you see areas like this where that does look like multiple layers of cells, but that's just a mirage. That's just something about how they cut the slide. It didn't come out picture perfect, but when you've seen enough examples, you start to recognize mirages versus what the tissue is actually supposed to look like. In this example, we have an open space and we have a layer of cells going this way and a separate layer of cells going this way. And it is just one layer of column-shaped cells. Now, something to note is that sometimes cuboidal cells look columnar, but cuboidal cells will have circular nuclei, whereas columnar cells will have oval nuclei. This is stratified squamous. You see all those rows of nuclei, which tells you there's rows and rows of cells, therefore it must be stratified. And we name the tissue for the cells at the top. These cells are flat little pancakes. That is why it is stratified squamous, even though towards the bottom they do start to look more cuboidal. We don't care about that part. As soon as you see cilia, you should suspect ciliated pseudostratified columnar. And you are going to confirm that is what that is by looking at those multiple rows of nuclei. Now, if you don't remember, why is this called pseudostratified, not regular stratified? Because all of these cells are attached to the basement membrane. They're all attached to the bottom. So really there's only one row. It's just that some of the cells are short and some of the cells are tall, so the tall cells have their nuclei up here, the short cells have their nuclei down there. And last but not least, our problem child, transitional epithelium. A lot of students, after watching my first video, still had problems with transitional. That's why I included a lot more examples in this one. The thing about transitional is it can look very different depending on where the sample came from, but it is always going to be stratified, meaning it has multiple rows. Usually you're going to see kind of dome-shaped cells, nuclei that are poorly organized, meaning like they're not in nice, neat rows. They're kind of all over the place. And you want to ID it by the process of elimination. So list all of the types of epithelium that you need to know in your head, and you can go right down the list and say, that's not simple squamous, it's not simple cuboidal, can't be simple columnar because it's stratified. And then when you think about the stratified ones, well, it doesn't have cilia, those aren't pancakes, and eventually you will come to the fact that it can only be transitional epithelium. So this is actually a side-by-side of something I did not include in my first video because students at my school do not need to know this for basic histology. So if you go to the school I work at, ignore this entirely. So the one on the left is stratified cuboidal. On the right is stratified columnar. So the cuboidal usually has circular nuclei. The stratified columnar, the nuclei at the top are more likely to be oval. If you're having a hard time telling if it is cubes or columns, try to look at the nuclei. All right, so this brings us into our actual practice questions. So I'm going to flip to each question. I'm going to give you 10 seconds to think of the answer, and then I will explain how you should have known what it was. So this is ciliated pseudostratified columnar. These cilia don't look like great cilia. However, you can definitely tell that they are tall, skinny cells. And then you have multiple rows of nuclei, which gives us our hint that it is ciliated pseudostratified columnar. We would not think that this is just stratified columnar because normally stratified columnar has nice organized rows of nuclei. So even if you can't tell that those are cilia, which you don't see in stratified columnar, the fact that these are not nice, neatly organized rows of cilia should tell you that this is not stratified columnar. This is simple squamous, easy enough, because you have one layer of flat pancake-shaped cells holding hands. So hopefully this was very obvious to you that this is transitional epithelium. So the first thing you need to do is find that bottom of your epithelium. And then you look up, you see multiple rows of nuclei, so you know it's stratified. Then you see that you have dome-shaped cells, which sometimes cuboidal cells might look dome-shaped, but the fact that these nuclei are kind of all over the place and not in nice even rows should tell you that it is transitional epithelium. So this is simple cuboidal. You've got one layer of square-shaped cells. So we're always counting from the open space and going away. So we find one cuboidal cell, and then you get down here, the tissue layer changes. So only this part is the epithelium. This is stratified squamous because you've got multiple layers of pancake-shaped cells. Now I will point out that as you go down in stratified squamous, the cells do start to look cuboidal, but we don't care about that part of the layer, we only care about the part near the top. Also, I will point out in stratified squamous, you oftentimes find a darker border towards the bottom of the epithelial layer, which is helpful when you're looking at something from far away. Even from far away, if you see that dark purple border, you should suspect that it's stratified squamous. So these are simple cuboidal. You have many examples of simple cuboidal here. Anywhere you see those little circular nuclei is a cuboidal cell. And the reason that this is not stratified cuboidal is because they all have their own open space in the center. So that's how you know that these are parts of different layers, because they all have an open space. This is an example of simple squamous. You can tell it's so thin, it's almost hard to even see it, but you see those flat little pancake-shaped nuclei, gives you the hint that there's epithelium there and that it is simple squamous. This is ciliated simple columnar. Most simple columnar is not ciliated. I believe you only find ciliated simple columnar in the fallopian tube. So it is very rare, but it does exist. Multiple layers of cells. It's not stratified squamous, not stratified cuboidal, it's not stratified columnar, it's definitely not ciliated pseudostratified. This is the only thing it could be, is transitional. So this is simple columnar. Now, sometimes when people see examples like this, they get confused because there appears to be maybe multiple rows of nuclei. Sometimes what you're seeing are cells behind it. Sometimes I'm not quite sure why it looks like there's multiple rows. It's just something about the way they cut it. This part here is like perfect textbook simple columnar, where it's very clearly only one layer of cells. But oftentimes it does look closer to this, where it almost looks like there's multiple rows of cells. But once you see enough examples, you'll realize it's just kind of a mirage. So this is not epithelium. I just wanted to include it. It's adipose. Most people know that one. This is simple cuboidal, but it is an example of simple cuboidal where you might say, hang on, those look like columns to me. Sometimes that happens. The cells don't look quite like cubes. It's something about how they cut it. But what gives you the hint that it is actually cuboidal is the fact that the nuclei are circular. And this is an example of simple squamous where it's so thin it's barely there. This is simple cuboidal, easy enough to tell because you have two nice rows of circular nuclei, which you would only see in stratified cuboidal. So you see multiple rows of nuclei with cilia, which you would not see in stratified columnar. It should be obvious to you that this is ciliated pseudostratified. So you may have thought that this one was transitional because it's multiple rows of nuclei and it doesn't look squamous. However, sometimes keratinized stratified squamous doesn't actually have cells that look clearly squamous, but you always see a kind of a flaky top. Once you see that flaky top, which is the stratum corneum, that is your hint that this is keratinized stratified squamous, not transitional. One layer of circular nuclei should tell you it is simple cuboidal. This is transitional epithelium because you've got multiple rows of nuclei, so you've got multiple layers of cells. We know that it's not the keratinized stratified squamous because we don't see the flaky top. So this is also transitional for the same reasons the last one was transitional. So transitional can look super different, but it's always multiple rows of cells, and you can always rule out any of the other cell types. If you are still getting transitional confused, tell me what you're getting it confused with, leave a comment, and I will try and sort you out. So I know these look like cilia, but this is actually non-ciliated pseudostratified columnar epithelium because these are stereocilia, which are closer to microvilli. At my school, and probably a lot of other schools, for basic intro histology, this is not an important distinction. This is a little bit advanced, so you don't need to freak out that now you need to learn about cilia versus stereocilia. I'm kind of just including this for informational purposes. But you should know that this is pseudostratified because, as far as I understand, stratified epithelium never has cilia or stereocilia. Of course, there always has to be one weird example. You do see that in the fetal esophagus. No one's showing you a fetal esophagus, I don't think, so don't worry about it. Also, once again, to the best of my knowledge, the pseudostratified always has either cilia or stereocilia. So when you see those projections and you see multiple rows of nuclei, you're going to guess pseudostratified. Now, I am almost 100% certain that I am right about what I just said, but this is a public service announcement. Always check my videos for pinned comments. I'm a human being, I make mistakes, but even in this case, if I am wrong, I'm almost certain that it won't affect you. If there are exceptions, I think they are such rare exceptions that you can almost just disregard them entirely. This is another example of non-ciliated pseudostratified columnar epithelium. It's also from the male reproductive tract. You can see there are tiny projections. Now, this is not the best slide, but it is the only example I could find. Once you see those tiny projections, you should think this is not stratified columnar, even though I will give you that it looks like stratified columnar, but it is not. You see cilia, you see stereocilia, just assume it's pseudostratified. Okay, so after this point, I have no more questions. I just want to talk a little bit more about what I found when I was hunting down information about non-ciliated versus ciliated, because if you Google that, an image comes up, and I would nearly bet my life that this image is wrong. So when I first saw this, my immediate thought was, I was wrong. There's no cilia or stereocilia there. But then when I looked a little closer, I saw this, What do you think this slide is? I don't think it's pseudostratified. I believe it is simple columnar. I think that this part of the slide is a mirage where you're seeing multiple nuclei where there aren't actually really multiple nuclei, and this is the part of the slide that got cut correctly, and that's why you're only seeing one row of nuclei here. And then I found this image on bio.davidson.edu. They say it's simple columnar. It looks almost identical to this picture, so I would be willing to bet that I'm right. This is simple columnar. And bio.davidson.edu, just looked at the school out of curiosity. They have an 18% acceptance rate. I feel pretty good about them. But now I do think they were right, but then on this same website, I found this picture, which they're saying it's stratified columnar. Those are very clearly, obviously cilia. And now I'm thinking, was I wrong? Can stratified columnar have cilia in something that's not a fetal esophagus? And then I looked at this description a little bit closer and I saw this. Intestinal lining. And I said, no, absolutely not. You do not find cilia in the intestinal tract. You find a microvilli in the intestinal tract. And the microvilli are for absorption, but they are definitely not to move nutrients. So I'm only showing you this so you know, trust no one, ever. I don't care what your acceptance rate is, Davidson. I think you had an undergrad student do this, and no one ever looked at it that closely. My best guess is that this is ciliated pseudostratified, and I'm basing that on the fact that I believe these are goblet cells, which you would not find in the epididymis, so I would think that these are actual cilia, not stereocilia, which would make this ciliated pseudostratified. Now that being said, this is a weird slide, and I fully admit there are things that I don't know about, so I, just for curiosity's sake, found the original professor that posted this. Even though this website is no longer functioning, they made a different one, and their contact information was on the page, so I emailed them and I said, please explain what we're looking at here. And I'm half expecting that professor's retired. But if I do get a reply, I will pin it in the comments. Alright, so that was a big tangent, and if you're still here, why? I'm just kidding. I hope this was helpful. If you have questions, please feel free to ask me in the comments and I will do my best to answer you. Have a great day and have fun learning.